Okay, for our first lesson, we're going to look at the three undefined terms of geometry, which are point, line, and plane. And point, line, and plane are pretty much the building blocks of geometry. A point is paralleled with a cell in biology. Everything in geometry is built off of points. It's the smallest unit of measurement, which we really can't measure it, but it's your smallest object possible. Just like in science, everything is comprised of cells. Same thing for the point. The point, line, and plane are three undefined terms. It's because we can't really give them a concrete definition, but we can give a description. So what we're going to do now is we're going to look at the point, line, and plane individually, and we're going to look at how each one of those figures actually we can represent in a drawing, and then we're going to look at how we actually name those figures using symbols. So let's start off with the first one, and let's start off with point. Okay, a point is exactly how it sounds. Okay, that's your first undefined term, point. Point is exactly as it sounds. So when we're looking at a point, we're looking at a single object. A single object that has no depth or thickness, it's just a point. So this is a point. That is the simplest representation of a point that you're going to see. We can have all kinds of figures. We can have multiple points. That can be point A, point B, point C. Those are all points. If I drew this object, those are three individual points that are on this particular line, and we'll talk about line in a little bit. So these are your points. Now for the points, there's a certain way that you can represent the point with a symbol. And the symbol for point is you pick that point. So let's say I pick any of these points here. Let's say I pick point B. For my symbol, point B will just be dot B, or I can just call it B, or I can write it as point B. Now, you will see this one and this one more common. Those are the most commonly used. This is technically still a picture, but sometimes you'll see that used as a reference as a symbol for a point. So once again, the point is the smallest object we have, and the points are the individual points, not the entire object, just the individual points. Okay, now that we've done point, let's do line. So our second object is going to be a line. Now a line is something that extends infinitely in two directions, but it has no thickness. You cannot measure a line because it does not have any thickness. It is not two-dimensional, it is one-dimensional. And it extends infinitely in both directions, which means we cannot take a ruler and measure a line. So if I were to draw a line, your basic line looks like this. These arrows indicate that it goes on forever, infinitely. This is going to go on infinitely. The line will never stop, okay? It cannot be measured. That's very important. You can't say, this is half of a line. This is a third of a line. You can't measure a half or a third of something that you can't measure. It goes on infinitely. You can't take half of infinity. So a line cannot be measured. That's very important. These arrows are critical in showing that it goes on infinitely, an infinite number of points. Now, when we name a line and we use our symbolic representation, you're going to see a line written in several ways. Here's one way with a few of the points named on that line. And there's another way where you see a lowercase letter, in this case it's L, but no points listed. So this indicates to us how we can name this particular line. So the first one, line PQR. When we name a line, we always use any 2 points on that line. Any 2 points on that line. So I can choose P and Q, or I can choose Q and R, or I can choose P and R. It doesn't matter. And to name it, you're going to use the line symbol, and then you're going to pick 2 points. So in this case, I named it PQ, line PQ. Okay? I also, if I wanted to, I could have switched those around and called it QP. It doesn't matter what order you use when you're naming these. The line that goes from P to Q and the line that goes from Q to P are the same line. So let's pick two other points. Let's say I chose Q and R. I could have called this line QR if I wanted to. And that's the same exact line as PQ because it's the same line that goes through all 3 points. Or I could just say line RQ. Again, the order does not matter because it's going through both points. So let's look at the last one. And now I would choose P and R. So this could also be line PR or line RP. So if I ever ask you to name this on an exam, or if you're ever asked to name this, as long as you pick any 2 points that are on that line, you're good. And then use the correct symbol. The arrows are important because they represent infinity. Remember, we cannot measure the length of a line because the line is infinite. We cannot measure something that never stops. Think about it this way. If you had a ruler, could you measure this? No, because it would never stop. Now, let's look at the second representation here with the lowercase. So if I use the lowercase, this is not a point, okay? And this is something you need to remember. It's very important. This is not a point. That's not a point. There's no dot there. This is not a point, and it's in cursive lowercase letter. That's how we indicate that that's a simpler way to name the line. Sometimes you have drawings and you have lots of different interactions. You have a lot of different figures, and it's easier to name a particular line with a letter like this than to add more points to the clutter, especially when you have a big picture. So we can call this line L. So you would actually write this line L. And that's how you would name it. So there's 2 ways to name a line. Using the 2 points, any 2 points on that line, or if you're given a lowercase letter, you can name it that way. All right, so let's look at the last one on here. We've done point, we've done line, and now it's time to do plane. Okay, point, line, and plane. Plane is the last one. Point has no dimension. A line has 1 dimension. A plane has 2 dimensions. A plane has 2 dimensions. It actually will go in 2 different directions. Talking about, you think about a rectangle as length times width. We really can't measure a length and a width with a plane, but it doesn't just go in a single space like a line. A line has 1 dimension to it. It goes 2 directions in the same dimension. This one has 2 dimensions to it. It's a flat surface that extends infinitely. So if I wanted, and this one also cannot be measured. That's important. It cannot be measured. You've got to realize that a plane extends infinitely. Think about your desk in your classroom. It extends infinitely. If that extended infinitely in all directions, that's a plane. So a plane also cannot be measured. And as for a line, and I'm going to go back and add this to the line because I think this is important. Okay, 2 points. There's an I in that. I can spell. 2 points determine a line. That means anytime you draw 2 points, okay, we'll also add up here that a line is 1-dimensional. 2 points determine a line. That means if I pick two random points anywhere, there's always a straight line I can draw between those 2 points. I can put a point here and a point here. There's always a straight line I can draw between any 2 points. So we need 2 points to determine a line. Well, in order to determine a plane, we need a 3rd point. Okay? So 3 non-collinear. And we talked about non-collinear. Non-collinear meaning they cannot be on the same line. 3 non-collinear points determine a plane. 3 non-collinear points determine a plane. Now, why do they have to be non-collinear? Well, let's draw our plane here. I'm going to do 3 non-collinear points right here. Okay, that means I can draw 3 different lines. That means if I were to extend this triangle, it goes 2-dimensionally. It can go this way in this way. It's just expanding. It's two-dimensional. It's flat. If it were three-dimensional, it would be like a solid, like a sphere or a cylinder. But we're just talking flat. Flat like a square, flat like a triangle, except not measurable, extending infinitely. Now notice these 3 points, okay? These 3 points are non-collinear. What is non-collinear? They're not together in a straight line. So 3 non-collinear points will determine a plane. Why do they have to be non-collinear points? Well, here's your example. If I give you 3 points here, and they're collinear, does that form a plane? No, it doesn't. That forms a straight line. It doesn't form a plane. I need a third point that is not collinear with the other two, which is in this case, the A is non-collinear with the M and the T. Or you could look at it as the M is not collinear with the A and the T, or the T is not collinear with the M and the A. Therefore, we have a plane. It just extends infinitely. Planes, you'll see them represented by triangles. You'll see them represented like this sometimes. A plane is a plane. If they call it a plane, it's a plane. It means flat, infinite, each direction, okay? So, a lot of times you'll see planes actually drawn out like this. And you'll be given points like this. So there's another representation. You're just going to have to learn to recognize all the representations that we get with each of these figures. You will also see a plane written like this. Something like that. So now let's look at the ways we can name these. Okay, the first one, this plane right here, the way you name it, if you want to use symbols, the correct symbol would be plane M-A-T. You could also call this plane T-A-M. The order, again, does not matter for these. Or you could call it plane A-T-M. Oh, we all love ATMs, right? Money. So there's 6 other ways you can name this. You could do TMA, you can go AMT, you can go TAM. There's 6 different ways you can name this plane. At least 6 different ways. There's actually more than that. So think about it. You can start with any letter. I can go TMA or TAM. There's actually six ways. Actually, exactly 6. AMT or ATM or MTA and MAT. So there's 6 ways you can name this plane. Exactly 6. Now let's look at this one. This is not a plane. So here, this could be plane MSN. Or it could be plane NSM. Or it could be plane SMN. Or it can be plane SNM. Okay? Or it could be plane MNS. It doesn't matter. The order doesn't matter. For lines and planes, it does not matter. So now let's look at naming this one. This is similar to the concept we did with the line. So instead of having a bunch of points, sometimes pictures get really busy and there's a lot of points. So instead of getting really busy, they will use a single cursive or italicized letter. Sometimes it's italicized, it's in italics, and sometimes it's cursive to name a plane. So this would just be plane R. And that's